I started recording. Okay, fine. So now you can see the slide.
Yes.
Yes, sir.
Okay. So this is one of the nice pharmaceutical drug which you get it in the market. Okay, ibuprofen. People use it when they have fever like that. Okay. So you look into this drug. It has a. It also comes as a two enantiomers. Okay. One is S is active form, which only helps you to get off your fever or get from the body pain. R is a highly inactive form. Okay. So, for example, if a doctor prescribes you 500 milligram of one tablet of ibuprofen, only 250 milligram is active, and the rest is inactive. Okay. So basically, if you buy for okay, let me stop here, and I will say, is this is going to justify you that to study stereochemistry is important?
Yes, sir.
Anyone?
Yes,
So
sir.
we have a racemic mixture in
Question.
the
Huh?
tablet. Then,
What?
Sir,
sir,
What?
we are
since we have
given
a
both
racemic
of them.
mixture,
Resonance structure? No, no, no. I'm just given the proper structure.
Sir, racemic mixture.
so I was asking that in
Yeah,
the
yeah,
tablet we
yeah,
have.
S form and R form. Yeah, both are there. Yeah, it's not a chiral compound. A chiral.
Sir, then why isn't
So
only
it
S
is
there?
not. So it is not.
No, no, I will get into the
Yes,
chemistry
sir.
part. You don't worry about the chemistry part. Okay, I'm
No,
just asking,
no,
is
sir. If
this
S
is
is only
really,
active, if S is only active, then why isn't S only there?
why is?
Why is S only there? Isn't S only there? Why is R also there?
Yeah, yeah, I will get you to that question. Fine. But my question was different. No? My question I asked you is it is really tells you to study stereochemistry.
So still not.
Still not
Sir, we are
anyone?
giving sir, we are giving half price for something that we are not using. It's
Very
useless.
good. So this helps you to study as an economist point, right? If you are a good
Yes,
businessman,
sir.
you are going to end up in earning double the money, right? Right, but it's not helping me to say why it is that much important. Run a year, another 250 milligram R is there. Okay, it's fine. So I want to answer another gentleman question. He asked me, another student asked, sir, if S is active, why R should be there? See, separating S and R itself is a highly expensive process. To separate the two chiral enantiomers are highly expensive. Okay, that's why if the R is inactive, people are happy to be there in the drug. Okay, if it is inactive, the separation is very expensive. That's the reason. Clear, sir? I hope I answered you one of the questions you asked. Are you clear? Someone
Yes, sir.
asked me that question, right?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So now S is active, R is inactive. So for business point of view, it is TK. So I am going to earn money. That is fine. But for as a chemist, I am not that much interested. Okay. Take this drug. Okay. This drug is called as amphetamine. Okay. The levo part of it, it is a cough relief, and the dextro part of it is a sedative. Okay. So tells anything valid?
Yes, sir.
See, the levo, that means the levo for the levo type of this compound, levo enantiomer of amphetamine is cough relief, whereas the dextro part is sedative. What is sedative?
So it's induces sleep.
Very good. So you feel anything great here? Stereochemistry is needed?
Sir, I think a doctor would like to study
Yes,
that.
sir.
But
Yeah.
why engineers?
See, most of the time, if you are sedative, okay, you end up in getting cough relief, right? The main principle of cough relief is what? To make you to sleep. And your
Yes,
whole
sir.
body itself will purify in 2-3 days if it is not that much infected, right? So if you take your cough medicines, most of the cough medicines will be having sedative. So you take and it helps you to sleep happily in the night, so that your in all this cough problem gets itself rectified. Okay, that is why we use that. So this is not telling me anything. Okay, still I am not convinced whether to study stereochemistry, but I am getting an idea that different form exhibit different pharmaceutical behavior, right? Or therapeutic efficacy. One is giving me a cough property, another is giving me a sedative property, even though they are same. Okay, fine. So till 80s, so people were not giving, not 80s, 70s, people were not giving much importance for this R and S and all these things. They were there. Okay, anyone heard about this? Thalidomide tragedy. Anyone?
So during the
Sir,
World War, World, World
That's
War
why I said 70s
II,
that people didn't care much about RNS, but after this tragedy, people started all pharmaceutical industry, US ka FDA, all these drug markets become very, 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 very strict because of this incident. Anyone have any idea what this incident is? Thalidomide tragedy?
Sir, it was a birth defect that occurred due to the wrong drug consumption, probably due to the wrong enantiomer being consumed.
Wrong drug, nahi wrong drug. It's not, you are there, but not exactly. Okay, I will tell you what is thalidomide tragedy. That's very important you to know. See, this working woman or any woman during their pregnancy time, they end up in this morning sleepiness, sickness. They end up in vomiting and all these things happens. Okay, that everyone knows that. In Western, that time, 80s, my Western people, working women were a lot. They were going for jobs a lot in 80s and 70s in US and Europe. And during their pregnancy time, it was really difficult for them. So I don't want to name the company. The company comes with a drug, okay, and they give, and that drug was sold in the market. And once people taken the drug, they found that they were having no morning sickness, and they were happy, and they were all going to the market, to the job, and they were all efficient. But after the kids or the child was born, all this one who taken this drug, their kids were found to be malformation. Most of their limbs were malformation. Still, these kids are there in US, and US government and the company is paying everything for these kids. They should be now not kids, they should be now 30 years grown up. So most of them had their limb malformation, and everything as something was really a problem. Okay, and this was really a big thing in US. So they went to the US federal government came into the picture, asked the company what is happening, and the company goes back and checks all the drugs. Okay, and you can see this is the R plus thalidomide, okay, which is basically a sedative which helps to get up and get away from your morning sickness. And they found this drug to be 99.9% pure. In US, if the drug is not 99.9% pure, it will not be in the market. So this drug was 99.9% pure, and it was in the market, 99%. But once they start looking into this very clearly, they found that 0.08% of, yes, another enantiomer was present, and they synthesized this enantiomer separately, and they tested, and they found this enantiomer is highly teratogenic. Teratogenic means it's a limb malfunction. You see now, so you have a compound in which 99.99% or 99.01 whatever percentage, it is pure, having an effective R form, which is a sedative, whereas there was another 0.08% of enantiomer, which was, we can call as teratogenic or non or toxic one. And the whole effective of the medicine completely changed. See what a thing, right? Then only now all the pharmaceutical companies in US, everything now they said that it should be 99.9% enantiomeric pure. Now all the drugs in US comes in the market will be 99.9% pure. Now you understand, is it is really important to study RNS form?
Yes, sir, very much.
Yes, sir.
Even a single change. So you should not come to me asking, sir, R form को yes लिख दिया, एक half mark दे देना sir. Because I have seen you guys coming to asking me, sir, instead of R I wrote yes, no, sir. Sir, if you give me half mark, I can get my A to excellent. Okay. So it's not justifiable, right? To asking that. You think? So if you change from R to S, you see what happens. The whole property of the molecule changes from a sedative to a teratogenic. Okay, I will show you some other examples also, which will make. Okay, any idea of DOPA? What is
Parkinson.
DOPA? Hey guys, you are all IITians.
Dopamine.
What is that used for? Where it is now used?
Creating
Very good, good, excellent. So the L-dopamine is used for neurodegenerative diseases, okay, particularly for Parkinson's disease. Any idea what is the difference between Parkinson's and Alzheimer?
I think Alzheimer has severe memory loss
Uh,
in old ages.
what is difference actually, scientifically?
I think Parkinson's affects the whole brain and they lose all neurological function. Well, Alzheimer's only the memory areas.
Sir, Alzheimer's is mainly memory centric, and Parkinson's is most probably movement centric. Like it affects the cerebellum.
So Parkinson is due to genetic defects.
Okay, very good. I get a lot of answers. So nice. I will add them. Okay, very good. One is a voluntary action, another is non-voluntary action. Affects the voluntary actions. Which affects voluntary actions?
Sir, movement is voluntary.
Okay, good. So anyhow, you guys know all these things. Very good. So you know about Parkinson's and Alzheimer. You see this drug, L-DOPA. Okay, it is manufactured and it is manufactured as a single enantiomer. Okay, 99.99% pure, and it is used as a Parkinson's disease के लिए. But if you take D-DOPA, okay, slightly different stereochemistry, and the whole drug is highly toxic. Okay, if you take D-DOPA continuously, you end up in dying. Okay, see how different they are. Another drug, naproxen. This people use regularly. I think all these anti-inflammatory drugs. This is, and yes, naproxen is highly anti-inflammatory, whereas the R is toxic to the liver. So I have shown you enantiomers where it can change only the properties like odor, taste, everything. There are enantiomers which are active and inactive in the pharmaceutical areas. There are enantiomers which is highly having pharmaceutical benefit, whereas the counter enantiomer ends up in highly toxicity. Okay. So once we are clear with this, now you have to tell me, is it is really need to study stereochemistry? Yes, right? You should study stereochemistry. Anyone says no after this? Sir, we need to spend time, no problem. We can spend time first, we should understand. That's why I said the cat race is over. Now it is all what you learn is very important. Okay. In your mind, whether you are an electronic or whatever it is, tomorrow once you graduate and people see you as an IIT and people think that you know everything. So you should know what they are. Okay. When you buy a pharmaceutical drug, you should know what is inside the drug. Always you should have an habit when you take a pharmaceutical drug, what is the ingredient in it? Okay. So that's why. So can we study stereochemistry? It is justified, right? Can we spend another 3 hours on studying stereochemistry? It's a
Yes,
waste
sir.
of time.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Thank you, sir. Thank you, sir. Okay. If you are if you are fine with studying stereochemistry, then we'll go and understand what are the stereoisomers which are there, and then we slowly understand one by one. There is no rush. You'll understand one by one till you are cleared. I am not going to go to another slide. Okay. Basically, isomers is a very important term which you guys like to know. Isomers can be classified into two types, right? One is constitutional isomer, another is stereoisomer. This constitutional isomer is nothing but it is a functional group change, which is nothing to worry much, okay? But today class we will be focusing on stereoisomers. Okay, not today class, just 9 hours we are going to focus on stereoisomers. So the stereoisomers can be broadly classified. Just a minute, I will just take the PowerPoint pointer. So the stereoisomers can be broadly classified as configurational isomers and conformational isomers. So configurational isomers is classified as geometric isomers, and optical is can be classified as enantiomers and diastereomers. So for your organic chemistry, I will be concentrating on what is enantiomers, what is diastereomers, what is geometric isomers, and what are conformations. So this is what we are going to talk for next 9 hours. Okay, first. Okay. Before getting into configurational isomer, that is about, we want to name the word chirality, or we want to understand the word chirality, how it begins, what is the origin of it. Okay. So we will leave the chemistry part and just term what is chirality. So chirality can be talked for anything. Okay, you can use these chiral words for not only for chemistry, you can use for anything. Okay, chiral is nothing but it is a non-superimposable mirror image, right? So you can see this bottle and the mirror images are superimposed. So we cannot call this as a chiral, whereas your hand is a proper chiral. Okay. So the mirror image of left hand cannot be superimposed on other self. Okay. This is about chirality, as simple as it is. So please, when you study newspapers and everything, you can also start using the word chiral. There will be many things chiral comes. Okay. Don't think chirality goes only for chemistry. You can use this word anywhere. So it should be non-superimposable mirror image. Very good. Guys, any wrong with this painting?
So the hands are superposable.
So the hands
So
are.
the hands
both
are
are
not
both
chiral.
are left hand
Okay,
side.
very good. So the ants are superimposable. So they are not chiral. So what tells you this? Any idea
Right hand thumb
what
should
is?
be on the other side.
Huh?
Right hand thumb should be on the other side.
Yeah, that's all fine. So it is non-superimposable. It's not chiral. But what you are thinking? What is this? Any idea what this painting? This painting is done in ancient Egyptian. So are you trying to understand? So that time people had less importance about chirality. That's what this whole painting is telling you, right? People were not giving importance of chirality. See how we have moved forward in science. That's what I am telling you. Okay, the chirality is not about finding a fault in the painting. It's all about understanding what people, that time people had less care for chirality of ants. See, chirality is very important. If you look into this universe, okay, you think the particular our solar system is chiral? Has any chirality? Or anything same you see? Anything you can imagine in this, in our universe, something, sir, everything is How is your planets are moving in this universe? Guys, no
Gravity,
answer.
sir.
No. How they are? What is their direction?
Ellipse.
Left to
Elliptical.
right, right?
Left, right.
It's not like Jupiter is moving right to left and Saturn is moving left to right. No, right? Everything is moving from left to right. That's why I'm saying if it is in the direct class, we can define this very nice. Left to right. You see many things. You see many things in our particular solar system will be most of the time left to right. How the sun rises, how it sets, how the clock goes, everything, how the plant, all these things you see, it will be left to right. So what it tells you now? See, I'm telling you how to look into science. That's why. Okay, I can. What it tells you now? Hey, brilliant guys.
So there is chirality in the universe as well.
So it tells you there will be another solar system where things will be right to left, right?
Yes, sir.
Yeah, that
Yes,
is.
sir.
Yeah, that's how nature starts. That's how this all this universe origin, all this has connections. People start understanding like that only. If everything left to right, there is something others where some right to left is going on. Okay, so the chirality, existence of chirality is not in chemistry. It is there in everywhere. The only thing you have to understand things. Okay, fine, good. Now, can we put this chirality in terms of chemistry? Now we have seen chirality with respect to universe and all these things. Now can we see chirality with respect to chemistry? So chemistry also comes in the same term. In chemistry also chirality we call, but we have some specific definition incorporated into this. We say that it is a non-superimposable mirror image. Very good. Just like what nature may be defined. But we further define it that for having a non-superimposable mirror image, all the substituent connected to a carbon should be different. Okay? So then we call that carbon. See, this is where we started. Okay? Then we call this carbon as chiral carbon or asymmetric carbon or stereogenic center. So how we define chemistry, chirality in chemistry? Chirality in chemistry is defined like this. It is a non-superimposable mirror image, very good. But it should say that there will be a carbon atom which has 4 different groups attached to it. Then you can call this carbon atom as a chiral center or center of chirality or asymmetric or stereogenic centers. Any doubt with this up to this chiralitica? If you have any doubt,
No,
you will
sir.
say, sir, I will forget this, sir, after 2 years means I will again repeat. You will not forget, right? There is nothing there to forget.
Excuse me, sir.
Yes, sir.
So actually in our coaching it was taught that chirality we don't talk about carbon, chirality we talk
Yeah.
about compound, and
Yes, yes,
related to
very good.
carbon we talk
Very
about
good.
asymmetric and
Yes,
symmetric.
very good. So what I said that I am talking about the chirality from the origin. Okay. So people understood chirality from carbon. Okay, then people move to nitrogen, sulfur, phosphorus, all these things. Okay, this is the definition how it started off. Clear? I will be definitely going for nitrogen and carbon. Okay, no worries. But this is the first definition. You should remember that. Hmm? Okay,
Yes,
sir?
sir.
Yeah.
Yes, sir.
So this is how it started. All this chirality. See, you look into this image. There was no chirality. This was in 17th centuries. And look into this image. This was in 18th century. Chirality slowly started beginning. People started understanding chirality. Then only all your DNA, helix, RNA, helix, all were left to right. People started enjoying chirality. Okay? And they were all enjoying with respect to carbon. Fine. First we'll finish off carbon, then we'll move forward to other atoms. Okay? Fine. So this is First thing on chirality. Okay, right. Do you want me to finish off chirality as you said? Fine, this is very good. So can you define me now chirality? The chirality is a carbon with 4 different groups attached, and we can call them as a chiral as a carbon. But my wonderful friend started me a question, sir, chirality is not only with respect to carbon atoms. We should redefine the chirality as a compound where you have a non-superimposable mirror image. Fine. So how this came? This is a very good thing. We should start knowing it. So I will now, what I will do is that I will just get my board, okay, so that we can think about chirality a little bit better way. So I will just share my board. Board. Just a board. Stop sharing. Okay. Yeah. So you will be having one question on chirality for sure in the exam. Okay. Can you see the whiteboard?
Sir, it is loading.
Yes, sir.
It's loading.
Yes.
Yeah. So it's fine, right? Okay. So what my the first point I will say, which you should remember. Okay. See, my drawing will be a little bit bad, so kindly adjust that. Is this molecule is chiral?
No, sir.
No, very good.
No, sir.
No, sir.
It's not chiral. Very good. Is this is chiral?
Yes.
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 Very good. Because they have 4
Yes,
different.
sir.
Diagram is not visible.
What's up?
The diagram, like the molecule, is not visible to me.
Why? For all it is
No,
fine.
No, sir.
Yes, sir, for me, it is
Only 2 points beside methane. Just now it is visible.
Now it is visible. Fine. Now it's visible.
Still not, sir.
No, sir. For my case, it's not.
Sir, we have to
No.
scroll the board right.
No, sir.
We have to scroll the board right side. Then it will be visible.
You have to.
Sir, it's a black screen for me.
For me
How,
also.
for everyone it is not visible.
Sir, it is perfectly visible. No,
Yes.
sir. For some, I think it is not visible. For some, it is visible.
Sir, I think whoever's using on phone is not visible.
Yeah.
Oh, yeah, man. Please.
Sir, could you
phone
share
it is
your
not.
entire
it is not visible to me.
Those who are using phone, you scroll the board right side, then it will be visible.
Yeah, yeah. For all that, yeah, phone use may scroll, it will be visible. Okay, this is as such, it's very important how definition changes. So we are happy with this one, right? We said that this is chiral. Fine, sir? Okay. Okay. Now I will take you to the next one. Sir, people started having a confusion here. Now you should be very careful this molecule. Is this molecule is a chiral?
No, sir.
No, sir.
No, sir.
This
No, sir.
molecule is not chiral. Okay. Okay, now you see now. Okay, this will be there in the exam for sure. Please try to understand. Why this is not chiral?
So because of
It's
like
not
there are
different.
same
It has
groups
to
as
be
well as
same
nitrogen
same
inversions.
groups, right?
Yeah.
Yes, sir. We have
Very good.
symmetry.
Very good. Very good. Very good.
So are you drawing something?
Yeah.
Sir, it is just a whiteboard.
Okay, come on.
Sir, it allows us to draw. Scroll it. No, it is read only.
Yes, the same for me.
Not
It's
visible.
first loading. Please see the methane.
You're not seeing anything.
Sir, only the first figure. After that, no.
Those who cannot see it can scroll the whiteboard with their fingers.
Yeah, I zoom out.
Now it is fine.
No, sir.
No, sir, not visible.
No.
So I will stop the
I
subject.
think
I will
maybe
again start.
network
Sir, for me, it's visible on the laptop and as well as on the phone. So I think they just need to scroll out, just zoom out.
Yeah, I zoomed out. There is only the first figure.
Come on.
I think there is network issue on their side.
So tomorrow then I will.
It depends on the network connectivity.
Yes, sir, they should join me again.
Okay, today you listen. Okay, tomorrow if you are not able to, I will download another Google board and I will try to use it. Let's see
Sir,
what
your
happens.
molecule is visible, sir. So just
Yeah.
slide downwards a little bit. So N and H is visible.
Okay.
So to the left, it's visible. Yes, sir. Just a little bit down. I guess it will.
Okay. No, okay. Now it is okay. Okay. So now this nitrogen. So you guys told in ammonia case that it is not chiral, right?
Yes.
Yes, sir.
Now, because you said that these three hydrogens are same. Now I am replacing the two hydrogens, one by deuterium, another by tritium. Okay, the isotopes of hydrogen. Now you tell me whether this molecule is chiral or not.
No, sir,
Not
it's not
chiral,
chiral.
sir.
Why?
Not chiral.
No, sir.
Because it has
Nitrogen
three
inversion.
different atoms.
Ring inversions.
Huh?
So nitrogen
Ring
inversion is present.
So
So nitrogen
then your concept of three different atoms goes wrong,
Sir,
right?
maybe
So
there's something we
yeah,
studied.
that's why I'm saying our definitions are modified, right? Now this is why this is happening, because here the ring flipping or ring inversion is very fast, right? That's why even if the nitrogen having three different atoms or four, I say with a lone pair, still it is not chiral. Fine, sir? Okay. Now take this nitrogen. So I am, instead of hydrogen, I am putting a methyl. Instead of deuterium, I am putting a chlorine. And instead of tritium, I am putting an hydrogen. Now let me know whether this guy is chiral or not.
Sir, if we put bigger groups, then the inversion is like slightly prohibited.
Yes.
So
So,
I think it will be chiral.
sir, this is chiral or not? How many are saying chiral or not?
Not
no
Sir,
one
it
knows.
may be both. We have to check experimentally.
Is this wrong? If I ask you in the
Yes.
exam, you will write like that. Exam में पूछेगा तो you will ask me to go and check the thing.
Sir, we should have some guideline like कितना
Very
बड़ा
good.
group के बाद
Very good.
inversion stops.
Very good. That's what. Okay. So the guideline says that I will explain to you. Okay. The guideline says that if the molecule has above 15 kilocalories per mole, then we can separate them and it exhibits chirality. Okay. This particularly has 22 kilocalories per mole. Okay. So now how to see how many energy, sir, energy I cannot know, sir, how to see. So what I will say that once you are replacing 2 hydrogen atoms of ammonia by a bulkier group, not bulky exactly, by chlorine above fluorine. Okay, if you are going to replace, then the nitrogen starts showing chirality. So the idea is that at least in ammonia, 2 of the hydrogens has to be replaced, okay, by other atoms, which is like bigger one. Bigger one means fluorine, chlorine, bromine, iodine, OHs, methyl, ethyl. Then this starts showing chirality. Though hydrogen should have to be replaced. Okay. So if your 2 hydrogens are not replaced, if you have a nitrogen molecule where you have 2 hydrogens, and even if a bulky tertiary butyl group, still it will not exhibit chirality. Okay. Any doubt?
Excuse me, sir.
Yes, sir. Go ahead, sir.
Sir, you said that 2 hydrogen groups are replaced by bigger than fluorine. Then CH3 is not bigger than fluorine.
No. I'm saying for an example. Okay, don't take that directly. Okay, I'm saying that if it is hydrogen is replaced by, basically what happens, hydrogen replacing, don't take the isotopes of hydrogens. Okay, other than hydrogen, that is starting from carbon. If you are going to replace it, you are going to end up with more than 15 kilocalories per mole, and you end up in chirality.
Sir, I am saying that CH3 methyl group is not bigger than fluorine. Then how
Yeah.
it can be chiral?
No, I'm not saying it is bigger than fluorine. I'm saying if it is replaced by hydrogen, I'm saying it should be a little bit bigger than hydrogen. That's enough, I'm saying.
Sir, what will be then in the case of NF3?
NF3, 3 fluorines are same. Ne?
Oh.
See, the first criteria, I have defined you the first criteria. First criteria says that it should have 3 different or 4 different substituents. That is the first criteria. Now you come to the second criteria. Second criteria in chirality, I am adding one more term. Okay, I am turning one more term called spin inversion or spin flipping, whatever you call them. I am saying that also should be considered for defining chirality. So if you are taking an ammonia type of molecule, you ensure that 3 hydrogens, though hydrogen, if it is replaced starting from carbon, then we can think of chirality there. You want me to repeat again? Yeah, unless you tell me only. Otherwise, I'm not going to move from here.
Sir, at least 2 hydrogen needs to be replaced, right?
Yeah. This question will be definitely there in the exam. You will get questions from like that only. Any doubt?
Excuse me, sir.
Yeah.
Sir, can you tell the reason that why this happens?
That's what I said. Now, this is, for example, this 3 hydrogens in ammonia can undergo a ring flipping or spin inversion very fast. Okay. So this 3 hydrogen and 1 lone pair, which is in the top. Okay. Here, this. Okay. They can flip like this. NH, like this. Okay. So this flipping, hey guys, Jarpala, Nikhil, don't talk with anyone. I'm taking class. So you can see this ring flipping, the lone pair goes down. So this process very fast happens. So I cannot say that the molecule exhibits here or the molecule exhibits like this. So to stop this flipping process, okay, if you have little bit bulkier groups, they will stop this ring flipping process, and that will enable chirality in the molecule. You can separate them out. See, for example, hey guys, this ring flipping, if I ask another question, okay, this ring flipping is how much? 2 calories per mole, okay? Yes or no?
Yes.
Yes, this ring flipping is only 2 kilocalories per mole. Eventually, if we end up in making an instrument which can separate molecules which are within 2 kilocalories per mole, then we will start calling them also as chirality. Right now, the chirality definition doesn't mean there because we don't have an instrument. Clear? So that's why I said this definitions of chirality keeps on adding. First, when we started, we said that if the carbon having 4 different groups is chiral, and it should be non-superimposable. Then we said, no, 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 not only carbon. It can be any molecule which has a 4 different atoms can be chiral. Then we added to that the ring flipping process should be such that if it is more than 15 kilocalories per mole or 20 kilocalories mole, then we end up in seeing the chirality. Any doubt how I am defining the chirality? See, I am taking a simple term and trying to define. I can just make a PPT and move forward, but I want you to know them completely. So shall I proceed?
Sir.
Yes.
Yes, sir.
Excuse me, sir.
Yes, sir.
Sir, can you reduce all the study that you're doing with this whiteboard thing and rather do something that doesn't incorporate this whiteboard, because many people cannot see what is happening on the whiteboard.
Can you use the whiteboard on available online for now?
Okay, I will use for next class. I will try to use this whiteboard. Okay.
Sir, I think there is a Microsoft whiteboard also that you can use directly from Windows.
Yeah, that's what I'm going to use for this class. Okay. So
Sir,
what
you
I will
can
do,
also write on PPTs as well.
Yeah, PPT doesn't give you that interaction. That's why I'm saying that. Okay.
No, sir, he said that we can also write, like use a blank slide and write on PPT.
Okay,
Yes,
okay.
sir.
Yeah, that is what I'm going to do. That no worries. Okay. So what I am going to do it here. Yeah, what you said is fine. So what he said is.
Sir, if only you can reduce this work that is being done on the whiteboard and do something that doesn't incorporate.
Yeah, definitely. I'm going to just do what you say. Okay, don't worry.
Thank you, sir.
I'm not going to, without teaching you, I'm not going to leave at any cost. Okay. Every one student should know this. Fine. So, do you see the slide now?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay.
Yes, sir.
Okay. So what I will do is that. So what is the time now?
Sir, it's 1 p.m.
Okay, fine. So next class, what I am going to do, I will bring the PPT, I will bring the whiteboard and see which is suitable. Okay, and then we will start working on it. Okay, don't worry. I will start. So chirality till today class, we will say that we have learned chirality up to carbon. It's okay.
Yes, sir. Tomorrow,
Okay.
please explain what you
Yeah,
have
we will
explained.
remove all the board work. Whatever I done in board work will be removed, and I will take that freshly. Okay. Okay.
Yes.
So what we
Thank you,
learned in
sir.
today's class, we learned why stereochemistry is very, very important. Yes or no?
Yes, sir. Yes, sir.
And we learned
Yes.
the chirality, the origin definition of chirality with respect to carbon atom. Is this two take-home message is fine with you for
Yes,
today's
sir.
class?
Yes, sir. Yes, sir.
Okay. Just have this two take-home message. From tomorrow class, I will start teaching chirality of other atoms. No worries. Okay, we have a lot of time. Don't worry. Okay, guys, but please come on time next class. Because of this board issues and all these things, if we waste time, it will be tough. Okay. Okay then. Thank you. Thank you for joining the class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.